Okay, so let's dig in. Today we're unpacking some pretty specialized hardware,
We are.
stuff that really bridges the gap between those big professional broadcast setups and, the internet platforms you use every day.
Exactly. We're focusing on encoding solutions
Mhm.
and specifically this interesting partnership between HDTV Supply, they call themselves a 25-year global home for AV gear,
Right.
and the tech coming from a company called Thor Broadcast. It's where that enterprise-level thinking meets the practical need to just get a stream online.
And the centerpiece in our sources is this one device, the Thor Broadcast H-SPARTAN-4.
Mhm.
It sounds serious. It's a 4-channel network encoder and streamer, and it's all packed into a single rack unit, which is that 1RU chassis.
And what's so interesting, I think, is the input setup. It's built to handle 4 modern HDMI inputs, digital
Oh,
feeds.
okay, standard stuff.
But,
Yeah.
and this is the critical part, it also have 4 CVBS inputs.
CVBS, so that's the old analog composite video.
That's the one, the yellow plug.
Hold on. If the whole point is modern, low-latency streaming, why would they build in support for, well, decades-old analog tech?
That's the smart move, you see. It makes the unit perfect for places like, say, a hospital or a university.
Places with older cameras still installed?
Exactly.
Yeah.
They haven't done a full upgrade on all their legacy systems. So this device democratizes pro-level streaming. It lets them bring those old systems into the new IP world without a massive overhaul.
That flexibility is, it's a huge deal. Okay, so if that's the strategy, let's talk technicals. What makes it ready for serious, reliable streaming?
Well, the encoding is built around H.Tape 264 for video,
A very common standard.
the most common, for a reason. It's about maximum compatibility. That's paired with flexible audio codecs like MPEG-1 or AAC. All of this works together to get you low latency and a really solid 1080p 60 video stream.
So they chose widespread compatibility over, say, chasing a higher resolution with something less common like H.265.
Precisely. It's a very practical decision.
And what about protocols? This isn't just for pushing video around an internal network, right?
Not at all. It can do the complex internal stuff like UDP-RTP multicast, which is, super high quality for a closed network.
Okay.
But the killer feature for public streaming is its support for RTMP with a key.
That's the protocol for YouTube, for Facebook Live.
Yep, it lets you stream directly to those platforms. No complicated middleware. It just simplifies everything.
And just for context, the sources list the price right now at $1,495.
Yeah, and there's also a smaller one-channel version, the H-SPARTAN-1, for around $895, so it's a whole family of products.
Right, and they're not just doing video encoding. The sources also mentioned these Thor Fiber XLR audio over fiber units.
I'm glad you brought that up. That shows they're really thinking about the whole broadcast quality picture.
How so?
Well, when you need to send professional audio over really long distances, like miles, you have to use fiber. Copper cables just won't cut it. They pick up all sorts of interference.
Like electrical hum and ground loops?
Exactly. Fiber is immune to all that. So offering that solution confirms they aren't just targeting cheap IP streaming. They're aiming for high-integrity professional distribution.
So wrapping this up, what does it all mean for you? This deep dive shows how this kind of specialized, flexible hardware is really bringing robust, broadcast-level tools right to the edge of the public internet.
It's making reliable, multi-source streaming much more accessible for everyone.
Right.
But this all raises a really interesting question for you to mull over. The sources say that internal multicast, that UDP-RTP, can need up to 14 megabits per second.
Okay, a lot of bandwidth.
But the public protocols, RTMP and HLS, they top out around 8 megabits per second. So here's the thought. How fundamentally different is the engineering challenge of guaranteeing broadcast quality when you have to cut your required bandwidth almost in half just to move your signal from that controlled private network to the Wild West of the public internet?